Hello and welcome to the screencast introducing the tangent function. Recall in a previous screencast we determined the side opposite of an angle pi over 7. First we used the cosine of the angle to find the value of the hypotenuse, and from there we were able to use the sine function to find the opposite side. We found that the opposite side was 5 times the ratio of the sine of pi over 7 divided by the cosine of pi over 7. It turns out that we regularly need to evaluate the ratio of the sine and cosine functions at the same angle as we did in this problem, so it's convenient to define a new function to be their ratio. We call the ratio of the sine and cosine functions the tangent function. Formally, for any real number t for which the cosine of t does not equal 0, we define the tangent of t, denoted tangent of t, to equal the sine of t divided by the cosine of t. Notice we don't want to divide by 0, so that's why the cosine of t cannot equal 0. Because the tangent function is defined in terms of the two fundamental circular functions, sine of t and cosine of t, we can use our understanding of these functions to make sense of the tangent function. In particular, we can think of the tangent of an angle from two different perspectives. We can think of it as an angle in standard position in the unit circle, or as an angle in a right triangle. Let's first think of the tangent of an angle as an angle in standard position on the unit circle. As the point corresponding to angle T traverses the circle and generates the point AB, we know that the cosine of T equals A and the sine of t equals B. Therefore, this point can also be thought of as the cosine of t, comma, the sine of t. Since the tangent function tracks the ratio of these two quantities and is given by the tangent of t equals sine of t divided by cosine of t, we could make a substitution and also think of the tangent function as the tangent of t equals B divided by A. We typically use this perspective of tracking the ratio of the y-coordinate B to the x-coordinate A of a point traversing the unit circle in order to think of the overall behavior and graph of the tangent function. Switching perspective and looking at any right triangle, not necessarily in the unit circle, with hypotenuse and legs adjacent and opposite, the known angle theta, we know that the sine of theta is opposite over hypotenuse and that the cosine of theta equals adjacent over hypotenuse. And knowing that tangent is defined to be tangent of theta equals sine of theta divided by cosine of theta, we can substitute the expressions for sine of theta and cosine of theta in the rule for the tangent function. So we'll see that the tangent of theta, which equals, again, sine of theta divided by cosine of theta, would equal, by these substitutions, opposite over hypotenuse divided by adjacent over hypotenuse. And multiplying both the numerator and the denominator by the hypotenuse results in the tangent of theta equals opposite over adjacent. We typically use this perspective that the tangent of angle theta is the ratio of the opposite side to the adjacent side whenever we are working to determining missing values in a triangle. So in future videos, we'll use the perspective of tracking the ratio of the y-coordinate to the x-coordinate of a point traversing the unit circle to study the overall behavior and graph of the tangent function. And we'll use the perspective in the right triangle to determine missing values in a triangle.